Hello, myself Dr. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss what is software architecture. The software architecture plays an important role in the software design, and this topic learning outcome is mapped with the course learning outcome of CO4, which is understand the importance and need of design, explain the various approaches of the design. So in this video, I will discuss briefly regarding what is software design, how it can be important, and what are the various design concepts, how architecture must be implemented with functional independence, how coupling cohesion can play a major role, what are various varieties of software architectures and which can be used for deploying different software projects. The software design is a mechanism to transform user requirements into some suitable form which helps the programmer in software coding and implementation. The requirements that gathered from the requirement phase with the help of various methods like on-site observation, interviewing, as well as graphical methods can be used for collection of the requirement. If the customer has a difficulty in explaining the requirement, then the prototype method can be used for the collection of the requirement. These collected requirements, after conduction of feasibility study, requirement engineering process can be applied. The validated requirements are documented in the SRS. These requirements can be visualized or modeled with the software design so that the software engineer can be easily apply coding and implementation techniques on this design. So the software design with representing client's requirement as described in the document SRS, software requirement specification, into a form that easily implementable using programming language. So in software design, the system is considered to be a set of components or modules. So on the basic principle of the design, the separation of concern, the project can be divided into small manageable units. Those can be called as components or modules. The structure of these modules and how they are related with each other to provide the intended functionality is clearly defined with the behavior and boundaries in the software design. So generally, two levels of design must be there. One is external design level, second one is internal design level. In case of external design level, the software design is concentrating on user interactions, how easily the project can be accessed by the users along with by crossing the boundaries, and how to design the user interfaces through application program interfaces is majorly considered in the external design. In case of internal design, the plans, the visualization, modeling and implementation methodology is basically focused in case of internal design. Generally, three phases of the software design are applicable. One is interface design, second one architectural design, third one detailed design. In case of interface design, the specification of interaction between the system and its environment is considered, and this phase proceeds at a high level of abstraction. what is the structure or architecture of the system, where the components can be implemented, how user can interact with these components is specified with high level of interaction. Next, the design problem statement produced during the problem analysis step should identify the people, the other systems and devices which are collectively called agents. So the stakeholders that are interacting with the system are identified, or the existing systems devices that are interacting with the proposed system are identified. So in the interface design, the major issues must be precise description of events in the environment, or the message from agents to which the system must respond. So how to access and how the system is respond to the external events must be understood in case of interface design. And the precise description of events or messages that the system must produce. So the input and output are majorly considered in case of interface design issue. By considering the GIGO concept, if you put garbage in, we can get garbage out. So specification of data, the formats of the data coming into and going out of the system is focused in the interface design. So the specification of ordering, timing relationships between incoming events or messages and outgoing events and outputs are clearly specified in the interface design issues. The second phase of the design is the architectural design. Architectural design is the specification of major components of a system, their responsibilities, properties, interfaces, and the relationship and interactions between the system. So in architectural design, the overall structure of the system is proposed, but the internal details of major components are ignored. So how these interactions and how their components can be implemented, the low level abstractions are hid in case of architectural design. The major architectural design issues are gross decomposition of the system into major components based on separation of concern principle, allocation of functional responsibilities to the components, component interfaces, component scaling and performance properties, resource consumption properties, reliability properties are considered. Communication and interaction between the components is a major issue in the architectural design. The third phase of the design is the detailed design. So design is the specification of internal elements of all major system components, their properties, relationships, and how the algorithms and data structures can be used for implementation of these components. The low-level abstraction is explored in the detailed design. So in the detailed design, each module is examined carefully to the design and the data structure and algorithms are focused. The stage outcome is the document in the form of module specification. Document is the output of this phase. The detailed design issues are decomposition of major system components into program units, allocation of functional responsibilities to the units, user interfaces, unit states and state changes, data and control interactions between units, data packaging implementation including issues of scope and visibility of program elements, algorithms and data structures. The general design process is majorly aims of design engineering is to generate a model which shows firmness, delight and commodity. So, software design is an iterative process through which requirements are translated into the blueprint for building the software. So, the pictorially model the functionalities or the features of the system with the design process. The major design concepts must be the abstraction, information hiding, refactoring, modularity, pattern refinement, architecture refinement. So, the design reflects the structure of the various components, how the properties and the relationship between these components. So, the abstraction must be used in order to represent the component at a high level by hiding the implementation details at the low level. And while communicating with the components, only the needed information must be shared between the components with the help of information hiding. This can be implemented in the programming languages with the help of access specifiers. Refactoring of the components are required so that a little change can enhance the performance of the application. Modularity is basically dividing the project into manageable components. Those are generally called as modules. Design patterns are the templates for the construction of the components as well as the user interfaces. The architecture reflects the blueprint or structure of the system under construction. Refinement can be used so that the changes must be, the change cannot be caused any unintended side effects so that error propagation can be prevented. So, architecture is the one of the design concept. So, it reflects the complete structure of the software. And this is the structure of program module where they interact with each other in a specialized way. The aim of software design is to obtain an architectural framework of a system. The features of the architecture is generally analyze effectiveness of design in meeting its stated requirements. So, the requirement SRS document must be converted into a model in the architecture which will analyze the effectiveness of the requirement. And architectural alternatives can also be made so that making design changes is relatively very easy. Reduce the risk associated with the construction of the software. So, the software architecture generally related with the development environment, the IT environment, and which type of process model can be used for the construction of the software, like waterfall model, agile software development, unified process, etc. And human dynamics, the stakeholders who are interacting with the project and the environment in which they are operating, and the business strategies, the transactions and business rules and organization or enterprise structure greatly influence the software architecture, and the design of the components and quality attributes are related with the software architecture. The quality attributes are generally coined with the term FOC. F means functionality, U means usability, R means reliability, P means performance, supportability. The functionality evaluates the feature set and capabilities of the program. Usability is accessed by considering the factors such as human factors, overall aesthetics, consistency, and the documentation issues are focused in the usability. Reliability is evaluated by measuring parameters like frequency, security of failure, output result, accuracy, and mean time to failure MTTF, mean time to recover MTTR from the failure or the program periodically. So this indicates how the software can be withstand until what time it can withstand regarding the failure, and it can be evaluated based on the parameters like mean time to failure, mean time to recover. And performance is measured by considering processing speed, response time, resource consumption, throughput and efficiency. The supportability combines ability to extend the program, adaptability and serviceability. And this is the another alternative term generally used is maintainability. Compatibility and testability are also the supportability issues so that the system can be easily installed and found the problem easily at the client site. So variety of architectural models are available. They are structural model, framework model, dynamic models, procedural models, function models. So in case of structural model, represent architecture as an organized collection of program components. The framework model increase the level of design abstraction by attempting to identify repeatable architectural design frameworks that are encouraged in similar type of application. So it produces the framework for the development of the software. Dynamic models addresses behavioral aspects of the program architecture, indicating how the structure and system configuration may change as a function of external events. Another type of architectural model is procedural model, focus on the design of the business or technical process that the system must accommodate. The last model is the function model and can be used to represent the functional hierarchy of a system. So, importance of this architecture is representation of software architecture enable for communication between all parties or stakeholders for the development of the application, so that the features of the software can be easily explained to the stakeholders and it can serve as the major means of communication in the project team. The architecture highlights early design decisions, so the profound impact on all software engineering work that follow and is an important for the ultimate success of the system, and it can reduce greatly the risk. Architectural constitutes a relatively small, intellectually graspable model of how the system is structured, how its components work together, they are related and implementable. The limitations of the architecture is there is lack of tools and standardized way to represent the architecture. Generally, few case tools and UML diagrams can be used for modeling purpose. Lack of analysis of method to predict whether the architecture will result in implementation that meets the requirement. Lack of awareness of importance of architectural design to software development. Lack of understanding of role of software architect and poor communication among the stakeholders. Lack of understanding of design process, design experience and evaluation of design. The goals of architecture is expose the structure of the system but hide its implementation details. Only high-level abstraction is concentrated. Realize all use cases and scenarios. Try to address the requirements of various stakeholders. Handle both functional and quality requirements. Reduce the goal of ownership and improve the organization's market position. Improve external confidence in either the organization or the system. Variety of architectural styles are available. A architectural style is set of principles. It improves partitioning and promoting design reuse by providing solutions frequently recurring problems. So reusability is possible with the architectural style. It is named collection of architectural design decisions that are applicable in a given document context, contain architectural design decisions that are specific to particular system within the context. So the domain and complexity of the project are considered and beneficial qualities in each resulting system is highlighted with the architectural style. The general taxonomy of architectural styles are independent components that are communicating processes and event systems, data flow architecture, data-centered call and return architecture, and virtual machine architecture. The data-centered architecture style will reside the center of the architecture and is accessed frequently by other components that update, add, delete or modify the data present within the store. This data-centered architecture will promote the integrability. So this means the existing components can be changed, new client components can be added to the architecture without the permission or consent of other clients. The general structure of data-centered architecture is the data store must be reside at the center so that the client's software can be added, deleted, modified when required without concern of other clients. The advantages of this architectural style is repository of data is independent of clients. Client work independent of each other. It may be simple to add additional clients. Modifications can be very easy. The next architectural style is data flow architecture. This kind of architecture is used when input data is transformed into output data through a series of computational manipulative components. So, these components are generally referred as pipes. Pipes are used for transmitting data from one component to the next. Each filter works independently and is designed to take data input from a certain form, produces data output to the next filter of a specified form. So, filter and pipes are the major components in the data flow architecture. These filters do not require any knowledge of working neighboring filters. So, this is the structure of data flow architecture. So, here the filters are majorly used for transforming one input to the next filter. The output generated is giving to the next filter as the input. So, the computational capabilities can be transmitted through the communicated through the pipes. The advantages are it encourages upkeep and repair processing and modification. With this design, concurrent execution must be supported. Next type of architectural style is call and return architecture. So it is used to create a program that is easy to scale and modify. The main program structure decomposes into number of subprograms or functions into a control hierarchy. Main program contains number of subprograms that can invoke other components. So this is the call and return architecture. The main program and it is divided into variety of control subprograms. These can be again divided into application subprograms. When their application subprograms are needed, the control subprogram can call them, which in turn must be called by the main program when required. Next architecture is object-oriented architecture. The components of the system encapsulate data and the operations that must be applied to manipulate the data. The coordination and communication between components are established via the message passing. So, class and object are the main component. In this, the class can be encapsulate the data and the operations. And the objects can be communicated via message passing. And these objects must be related to one another in a mesh architecture. The advantages of this is it enables the designer to separate a challenge into a collection of autonomous objects, other objects aware of implementation details, allowing changes to be made without having impact on other objects. The next architectural style is layered architecture. A number of different layers are defined, with each layer performing well-defined set of operations. Each layer will do some operations that become closer to machine instructions set progressively. At the out layer, components will receive the user interface operations, and at the inner layers, component will perform the operating system interfacing. So, the communication and coordination with the operating system. Intermediate layers to utility services and application software functions. So, here is the layered architecture. This is the core layer, utility layer, application layer, user interface layer. So, here the implementation, communication, coordination with the operating system services must be possible. So, in this video, I discussed about what is software design, what are the design process, design concepts. In the design concept, how architecture is important, what are the features of the software architecture, what are various architectural models and architectural styles, and the references used in this video are this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.